Any kind of okay now. Hello everyone. We should be online now. Please tell us if there is any problem with the sound or anything. And Joaquin, do you want to present the event?
Yeah, well, hello and welcome everyone. Welcome to SETI from Inside. This open discussion / interview that we have organized today we, the Astrobiology Society, of whom I'm the president, and we also have Marco, our finance director, Luna, our events officer, Silvia,
Any
our
kind of okay
secretary,
now.
and Sam,
Hello
our outreach
everyone. We
coordinator.
should be online now. Please
Will
tell
are
us if there
hosting
is
this
any problem with the sound or
conversation
anything.
between
And Joaquin, do
Michael
you want to
Garrett,
present the
the
event?
yeah, well,
Director of
hello and
Internal
welcome everyone.
Master
Welcome to
Physics here in
SETI from
Manchester,
Inside.
and
This
also
open Andrew Siemion, the director of the SETI Centre
today.
Berkeley. So, well, welcome everyone, and welcome Mike and Andrew. Thank you for joining us today.
Thank you for having us.
Yeah,
our pleasure. Yeah. So, well, I don't know. Mike, is your connection good enough for you to go ahead?
I don't know. You can, if it isn't, then you can tell me. Maybe I'll just put my video off.
Up to you. It seems it's working.
Yeah,
it's working. Okay. Yeah.
So, well, thanks for having us here, and it's always great to be part of the work that you guys are doing with the Astrobiology Society and in Manchester. Always a pleasure to help out and share what's happening in the world of SETI research and astrobiology more widely. It's definitely a pleasure to have Andrew Siemion here. Andrew and I have been good friends for almost a decade now. We met in Naples back in 2012, or in Italy in 2012, and since that point onwards, we've been close collaborators. So he's in Manchester at the moment. So I thought this would be a great opportunity for you guys to meet him and to discuss a little bit about what he's doing, and especially what the Breakthrough Listing initiative is doing. Andrew, do you want to say a few words of introduction about your background, where you came from, and what you're doing now, and then I'll ask a few questions.
Sure. Well, it's likewise very much a pleasure to be with you all. As Mike said, we've been friends and colleagues for some time. And Manchester is, of course, a very, very special place. At present, it's one of the few places that, for example, has a PhD student working in the search for extraterrestrial intelligence. And I think also one of the few places where there are some really significant opportunities to get involved in SETI research. And so I would certainly encourage anyone of you here joining the call or watching online to consider that as you start to look for undergraduate research opportunities or other research opportunities later in your career. I began my academic journey at a junior college in California. I spent 2 years at a junior college, and then I transferred to the University of California at Berkeley. I received my bachelor's degree at Berkeley in astrophysics in 2008. I then stuck around at Berkeley to be a PhD student and received my PhD in 2012. I actually started doing
I think we lost you there, Andrew. I mean, you're still on camera, but it's sounded, which is not what it's not working. Well, I think we're kind of used to this. Some problems by now.
Sorry, we're both using the same Wi-Fi in a hotel in Manchester. It doesn't seem to be working very well.
That's weird. Perhaps it's I don't know if you can hear us, Andrew. Your headphones something. I think he is gonna try to rejoin. He was unmuted at the time, but just
I almost think we might be better using our phones.
one never knows. Yeah, well, I mean, next time they come, hopefully we can host this in person or something. Let's see if I think he's just gonna try to rejoin. So let's see if that works. If it works that way.
Yeah, I might try and rejoin via my telephone.
Okay, he's here now. Hi, Andrew.
Hello again.
Yes, it's working now.
Yeah, sorry about that. My AirPods paired with another device in the room I'm in, so I started hearing something else.
Oh, that's.
Let's see. In any event, where was I? So I started doing SETI research in 2005. It was actually the first undergraduate research project I got involved in at Berkeley, and continued doing that research during my PhD. I received my PhD in 2012. And then actually the first opportunity Mike and I had to work together was actually during my first postdoc, which was with Mike when he was at an institute in the Netherlands called Astron. Then I spent about 3 years as a postdoc, and in 2015, pretty much everything in the world of SETI changed very significantly with the launch of the Breakthrough Listen initiative. This is a 10-year, $100 million search for extraterrestrial intelligence that's funded principally by Yuri and Julia Milner through the Breakthrough Prize Foundation and the Breakthrough Initiatives. Breakthrough Listen is conducting the most comprehensive, sensitive, and intensive search for extraterrestrial intelligence in history using telescopes all over the world, including the Lovell Telescope and other facilities in the UK, including E. Merlin. Mike is a member of our advisory board. So perhaps that's a sort of reasonable introduction.
Quite reasonable,
Okay.
really. Yeah. Okay, we can hear you, Mike. Yeah.
Yeah, I've moved to my telephone. I think it's got much better connectivity than the internet here.
Sounds working.
Yeah. So Andrew, maybe you can tell us, Breakthrough Listen, probably some of the people on the call, maybe don't know quite exactly what you're using, but, maybe you could say, what is it you're really trying to do?
So I think I got most of that, which is to talk a little bit more about Breakthrough Listen and how.
What's the big prize at the end of all of this?
Okay.
Yeah.
So
disappeared.
Yeah, I only got like about sort of every 10th word or something, but I'll do my best to answer the question.
Let's see.
Nonetheless, I don't know what it says about our ability to communicate with extraterrestrial intelligence when we have this much trouble communicating with one another. But in any event, SETI is an acronym. It stands for the Search for Extraterrestrial Intelligence. And the topic of SETI, the field of SETI, seeks to quantify the distribution of advanced life in the universe by looking for something called technosignatures. A technosignature is analogous to a biosignature. It's some remotely detectable evidence of advanced life, intelligent life that created a technology. And probably the most sort of well-known technosignature are narrowband radio signals. These are radio signals similar to those that human beings have produced for the last 100 years or so, but it also includes things like lasers or Dyson spheres, very large structures that a very advanced civilization might build around a star, for instance. Most of SETI is searches for electromagnetic emission, direct electromagnetic emission from technology. And the kind of distinguishing feature of that radiation that we use to tell the difference between natural sources and artificial ones is compression of electromagnetic energy in either time or in frequency. Most electromagnetic emission produced naturally has at some point some kind of randomness or stochasticity to it. And that causes the electromagnetic radiation to be broadened in either time or in frequency, whereas technology has a great deal of order and can compress energy into scales, time and frequency scales that nature cannot do. So that's the basic kind of signal that we look for. And I think I also heard Mike ask something about what's the prize at the end of this. Well, of course, the biggest prize of all would be the detection of advanced life beyond the Earth. That's, of course, the goal of our experiments. But thus far, we've, of course, had null results. We haven't yet detected advanced life beyond the Earth. I think that we will. But we have published a number of papers that constrain the sort of population of advanced life, particularly in the nearby parts of our galaxy. And so we can use these null results to put interesting statistical limits on the presence of at least intelligent life of the variety that produces the kinds of signals that we're able to detect.
Yeah, I think that's a very good summary. I don't know if Mike gets how is some going on, Mike, now?
Yeah, I think it's okay.
Okay, it is okay now. Yeah. Your question had been flagged, but it's working now.
I think it's better.
Yeah.
So, if you detected, a signal, and you'd gone through the, you were really convinced that it was real. What would you do next?
Well, this is a great question. It depends on what kind of signal, but I might call you, Mike, and ask for some director's discretionary time on the Hubble telescope to follow up on it. Of course, that we're astronomers and we're looking at astronomical phenomena, and really the most important thing is to conduct more observations. If in astronomy we see something interesting in our data, we want to observe it with other telescopes and make sure that it's there and try to characterize it further. And indeed, that's really the first thing that we think of. Beyond that, there's actually an organization called the International Academy of Astronautics that has a sort of a subgroup within it called the Permanent Committee on the Search for Extraterrestrial Intelligence. This is an international community of scholars across different disciplines. It includes, of course, astronomers and engineers, but also theologians and experts at law, experts at anthropology and sociology. That Mike happens to be the chair of this organization, this body, that has basically published a set of protocols that any researcher that discovers a signal from advanced life beyond the Earth should follow. And I think there are kind of two fundamental premises of that sort of agreement. One is a commitment to transparency, which means that we don't keep anything secret. We don't sort of withhold the detection within our own research group or within our own country. We're transparent to the world and to humanity about what we find, and also a commitment not to respond without due consultation with the planet. Essentially, I mean, any signal that we might receive, if it's intentional, it's certainly not intended for one research group or one country. It's intended for all of planet Earth. And if it's inadvertent, then of course it's not intended for anyone. And I think that there are good reasons that we should be contemplative, I think, about whether or not we might respond. And so I think it's an important part of these protocols that we don't respond until there's been discussion.
And popping a few bottles of champagne, is that also on the agenda?
Yeah, there's a story which is actually it is not at all apocryphal. It is a true story, in fact, that some SETI research groups do keep a bottle of champagne in the refrigerator anywhere they conduct a SETI search. Myself, I usually have champagne in my refrigerator for other reasons, and I think that this is SETI is something that can be celebrated continuously. I don't think that we should necessarily wait until that detection. I think that we can celebrate progress without having actually detected advanced life beyond the Earth, because after all, it might be hundreds or even thousands of years before we're able to make this detection.
Good. But Joaquin, I see there's at least one question in the chat. Is this the time to move over to other questions?
Definitely. I mean, yeah. Sipsankar, who is on the call, it has asked if there are scientists from other backgrounds, like, for example, cognitive science and linguistics, working at SETI.
Yeah, absolutely. I think one of the things that I think our research group, Breakthrough Listen certainly, but the SETI community in general, aims to do is to encourage interdisciplinary thought around the question of whether or not there's other advanced life in the universe, and indeed how we might go about detecting it or telling the difference between living and non-living systems. And there are certainly linguists and experts at machine learning and artificial intelligence and data science, electrical engineering. And as I mentioned with regard to this permanent committee on SETI, anthropologists and sociologists and experts at law and many other domains. I think the search for extraterrestrial intelligence is, in my opinion, perhaps the most interdisciplinary research field, certainly in astronomy and perhaps even in science as well.
Yeah, I think we need as much help as we can get from all sorts of different disciplines, and I think it's one of the things that attracts me to the whole thing is that, especially under the auspices of the International Academy of Astronautics, the SETI Permanent Committee, that you meet people, and we have members that just cover the whole spectrum of different areas of expertise, and for me, we don't know the answer to the question, is there intelligent life out there? And I always say that, everyone, even anyone in the street has just as a pertinent opinion on this topic as myself or Andrew, because we don't know the answer, and we need as much help as we can possibly get, and we need to have as much expertise, even if we make a signal, if we detect a signal, we probably need even more help about, how we go about, exploiting the information in that signal, how we convey that information to the whole general public, how we potentially respond to such a signal. So it is one of these great, everyone's interested in this topic, and we know so little, really substantially about it, that everyone has a voice, everyone has an opinion, and these are only good. These only push us in the right direction towards success in SETI actually detecting a signal.
Yeah, I mean, I think that's definitely a right point. It was your loop. I did wanted to ask one question that perhaps, I don't know if it probably doesn't have an answer, but perhaps you two can actually give us some insights. So as you have mentioned, Andrew, the Breakthrough Listen program was set up in 2015 for 10 years. So what will happen after 2025? And if that doesn't have an answer, what would you like to happen? What would you what can we just expect to happen after that date? Well, either two of you, I guess, you two have an answer.
I've been answering this question a lot lately for a variety of reasons. I think certainly I would hope that the research program continues. We're certainly not slowing down. We began with 3 telescopes in the Listen program and just a couple of researchers, and now we have something like 22 different telescopes that are participating in the Listen program in some form or another, and many hundreds of people around the world. including a very large number of undergraduate students and master students that are working in the field. So I would hope that we would continue after those 10 years. But if we don't, I think we will have set, we in fact already have, and much of this research has been led at Manchester. We've set the most stringent limits on the prevalence of intelligent life in the universe. We have conducted the most significant SETI searches that have ever been performed. We've developed a great deal of technology and algorithms for future SETI searches. Published a number of papers. It's often said that in science you stand on the shoulders of giants, and I think that we hope to have kind of raised the shoulders, I guess, a little bit in the field of SETI. Built a few rungs on the scientific ladder, so that other students and researchers that come after us can do yet better searches. I think it's also, a good thing to mention that the field of SETI in the last 5 or 6 years especially has experienced a real renaissance. There are many more people involved, and actually many more opportunities to get involved. And in the 6 years since LISTEN has started, we've had students go from being undergraduate researchers with us to graduate students receiving PhDs, and now beginning postdoctoral research in the field. And I think one very important outcome of Breakthrough LISTEN after 10 years, whether we go on or not, or whether we make a detection or not, is that we will have reinvigorated the pipeline of academic researchers and scientists that will propel the field of SETI into the future.
Yeah, well, thank you for that. I don't know, Mike, if you have, assuming probably similar views, but
yeah,
anything to that?
I'm interested. There's another question in the chat, maybe to ask Andrew.
We have Melissa, which has just asked, which calibration methods do you use on the data you collect in SETI?
This is a great question. We observe astronomical sources with known properties. This is the kind of standard way that radio telescopes, at least, are calibrated, and even optical telescopes. We can observe, say, with an optical telescope that has a spectrometer on it. We can observe stars with known spectral properties, known spectral lines. And we can use that to make sure that the telescope is working, that the instrument is working, that our data analysis pipelines are doing the right thing, so to speak, and very importantly in SETI, how sensitive the observation is. Ultimately, the limits that we place on the presence of technosignatures is a function of the luminosity, or the pseudoluminosity of the transmitters that we look for. And so we want to be able to accurately define what the sensitivity of our experiment is.
Does that answer your question, Melissa? I hope so. But if not, feel free to pop it in the chat, whatever you want. On this note, that since we're kind of touching more technical bits, I do recall correctly from a paper you put out in 2019. I think it was obviously SETI. It's the Breakthrough LISTEN program is focused on as opposed to previous attempts. It's a more comprehensive survey of our neighborhood, pretty much. But if I recall correctly, a core bit of it has been especially focused on a number of stars in a particular radio wavelength. Could you tell us a bit more on why has this been the focus during the effort during that time?
Well, we look at lots of different kinds of objects in the Breakthrough LISTEN program. The fundamental observational goals of Breakthrough LISTEN is to search 1 million nearby stars, certainly in the radio, and perhaps in the optical at some point as well. conduct a survey of the Milky Way galactic plane, an aerial survey over that area on the sky, and also observe some 100 nearby galaxies. And in thinking about that, that list of targets, of course, that there are also different techniques that we can use to observe these. So we observe, obviously, with radio telescopes and optical telescopes and other facilities as well. There's also a category of objects called exotica. These are just sort of interesting astronomical sources of one form or another, anomalies, things like Voyagian star, if folks are familiar with that object, and the like. We also employ a wide variety of different kinds of analysis techniques. So traditionally, SETI searches have concentrated on a few very specific prototypes of technosignatures that are informed by the kinds of technology that we've produced. But we also try to undertake searches for anomalies, just sort of generically kind of weird things that we see in our data, which is a much easier thing to articulate than actually to do. It's a huge challenge, particularly in the radio part of the spectrum where we're plagued by human interference, the signals that come from our own technology.
Okay, that sounds really definitely interesting, and yeah, I mean, I think it's the effort that has been made in making that extremely systematical and covering, as you have said, different aspects that haven't never been covered really in the Search for Life. I think that's already definitely providing some insights. I don't know, Mike, if you have any other questions, but I do have another one that has just popped in my head, which can be a bit abstract, I guess. But I wanted to ask, so imagine that we are in 2024 and you are asked to perhaps set up again another program for another 10 years, funding good conditions. So if this was to be the case, is there anything you would perhaps change or do differently, or anything that you perhaps we haven't had the chance of covering now, and now that we have the knowledge that we have collected from these 10 years, you would like to build upon?
Well, the nice thing about SETI and about astronomy in general is that telescopes are always getting more powerful. In 2024, 2025, we're going to start to see the kind of next generation of radio telescopes and optical telescopes start to come online. On the radio side, we're gonna start to see the first phases of the so-called square kilometer array. This is a next generation radio facility that's actually headquartered out at Jodrell Bank, and ultimately we'll have a square kilometer of collecting area. It will be something like 10 or 20 times as sensitive as our most sensitive radio telescope. So that's certainly something that we're looking forward to in the Breakthrough Listen program, and we're doing everything that we can to kind of lay the groundwork for being able to use that facility. We're also going to start to see very large optical telescopes come online, ground-based telescopes, 30-meter class telescopes, and I think these are going to be very interesting facilities for, among other things, spectroscopic optical SETI. There are also a number of regions of the parameter space that we simply haven't gotten around to looking in yet. This concept of looking for energy compression in time or in frequency can really be applied equally across the electromagnetic spectrum. And so we've done quite a lot of these types of searches in the radio part of the spectrum and in the optical part of the spectrum, but not so much in the infrared, for example. There are some very straightforward opportunities to do this in the near infrared. In the radio side of things, we've done quite a lot of SETI between about 1 and 10 gigahertz of radio frequencies, but much less at higher frequencies. And there are some phenomenal high frequency radio telescopes like the Atacama millimeter array in Chile, ALMA, which I think would be a fantastic facility for SETI as well.
That's indeed promising. Actually, in this context, we have another question from Melissa, which is that if there is a wavelength band that it's where SETI research is more difficult at, kind of been answered more or less, but
well, I think probably the most difficult wave bands are those that can only be observed from space. Our atmosphere and our ionosphere, in the case of low frequency radio signals, blocks certain frequencies or wavelengths of electromagnetic radiation from reaching the Earth. And so anything is harder in space. So that's maybe the most straightforward answer. I think, and similarly, regions of the spectrum that are very affected by the atmosphere generally, maybe that can get through the atmosphere, but are nevertheless affected by it, attenuated by it, or blurred by it, are also more challenging.
And we do have another question, which is that if the James Webb Space Telescope will have an impact on SETI research, or if there's, I assume, any time in reserve.
Yeah, most definitely. I mean, the thing that JWST will do generically is allow us to see the universe in new ways and learn more things about a wide variety of different kinds of objects. And astronomical discovery is itself a form of the search for extraterrestrial intelligence. We don't know necessarily how extremely advanced life might manifest. It might be some kind of signal that we know to look for, or it might be something completely unexpected. And certainly a telescope as powerful as JWST will find interesting new things, which will have an impact on SETI. I think in a little more kind of specific note, one of the areas of SETI that's received a lot of renewed attention in the last couple of years is actually looking for spectroscopic signatures of advanced life in the atmospheres of extrasolar planets. So one thing that JWST will do, of course, is look for biosignatures, signs of basic life in the atmospheres of extrasolar planets. Perhaps some of those observations might uncover some chemical component in the atmospheres of an extrasolar planet that we wouldn't expect to occur naturally, like a chlorofluorocarbon, for example, or some other molecule that we wouldn't expect would kind of thermodynamically naturally occur in the atmosphere. And these are another example of technosignatures, and something that perhaps JWST will find.
Yeah, I think that we are all really looking forward to see those results. And staying on technosignatures, I do have another question in that sense. So, how easy is to determine those technosignatures that perhaps we haven't experienced ourselves yet? Because I guess that we can, as it perhaps happened with a search for biosignatures, and that's when this shadow biosphere expression sometimes comes to the play. We know which technosignatures perhaps we produce, but how can we search for those that we might, or how can we detect, or how can we know that it's a technosignature if we ever bumped into one that we might just not have produced ourselves yet, if we ever do?
Well, this is a hard question. We don't know what we don't know ultimately. And I think, oftentimes this is sort of implicitly assumed, but I think it's worth explicitly stating it, that there is a fundamental anthropocentric bias in the search for extraterrestrial intelligence. We are informed about what advanced life can do based on our own experience as advanced life. And there is only one example of, let's say, electromagnetically capable technological species on the Earth, and that's human beings. I think that probably the most interesting way that we can attack this from the perspective of SETI is, I think, what I mentioned before, which is generic anomaly detection. Simply looking for something that we don't expect the natural world to do based on our understanding of the natural world, something that would be artificial. And there are lots of examples of that that are things that we don't yet do as a technologically capable species, but we imagine some very advanced life might do, like Dyson spheres, for example. But again, there is also a fundamental anthropocentric bias there as well, because we're using our own imaginations to think about what advanced life might do. And it's possible, in fact, maybe it's even probable that at least some advanced life manifests itself in ways that it is simply impossible for us to comprehend at this stage of our evolution. And in that vein, perhaps the evidence of advanced life in the universe extraterrestrial advanced life in the universe is right in front of us, and we just don't recognize it.
Yeah, I mean, who knows really? I guess that until, as you had said, it's just a really ongoing issue that we simply don't know what we don't know. So I think I want to throw another hard question, but as you last week we hosted a panel where we had Avi Loeb, and while discussing with him, the Breakthrough Listen program came through. He just raised a point that I wanted to discuss with you, and is that he is part of the Starship project, also funded by Breakthrough Initiatives, as you know. So I wanted to ask, even if you might be slightly biased, but I guess that you might have the answer, just because of you working on the Breakthrough Listen program. But why radio signature? Why radio signals as opposed to anything else? Are they especially? Could they be more insightful than anything else? I guess that they have some special benefits that perhaps with our current technologies are the maximum we can aim for, or what do you think?
Well, this is a good question. So first, I should reiterate that the Breakthrough Listen program searches across the electromagnetic spectrum. We focus a significant amount of our attention on radio telescopes, but we're certainly not sort of oblivious or otherwise blind to other wavelength regimes. And in fact, I think ultimately we would like every major telescope, be it ground-based or space-based, operating at whatever waveband, to be engaging in the kinds of searches that we're doing. All of that said, radio signals are very interesting to us. One, it's the first detectable evidence of our technology that was detectable at interstellar distances. It's very easy to tell the difference between an artificial radio signal and a natural radio signal, at least in terms of spectral compression, the so-called bandwidth of the signal. But maybe most importantly is that it's very easy for radio photons to get through the kind of gas and dust that exists between the stars. So we can detect radio signals over very, very large distances. And in fact, the type of signal that's produced by the Earth that is the most obvious indicator of our existence as a technologically capable species is in fact our radio emission.
Yeah, I think it's definitely true that that this has a lot of potential. We do have another question from Melissa as well, which is which definition of life is the SETI research working around, and if there is a specific one at this stage. She also asked, how does SETI define intelligence or advanced life? So is this linked to, she asked, the Kardashev scale or any scale by the case?
Yeah, this is a kind of a sticky subject. We have a operative definition of life and advanced life, and that is life that creates the kind of technosignatures that we're looking for. We don't have a comprehensive definition of life, and this is one of the biggest questions. Maybe one of the if not the largest question, which is kind of related to SETI and the search for life generally, which is what is life exactly? And we don't have a general definition of it. We certainly use the Kardashev scale to articulate the kinds of civilizations that we look for, and it's a kind of a helpful kind of gauge to kind of qualify the kinds of searches that we do in terms of the energetic properties of those civilizations. So it remains very, very useful even 50, 60 years, I think, after Nikolai Kardashev proposed the scale.
Yeah, I think that's definitely insightful. We've talked about, we've covered sometimes this kind of topics, but it's definitely, we've presented in our social media sometimes the Dyson spheres, Kardashev scale, obviously this kind of concepts, but it's always good to see that they are actually applied when it comes to research. We have another question from Sankar, which is revolves around communication. So provided that we get to encounter some either advanced or at least similar in a civilization, a similar stage, how do we communicate with it when we cannot even, obviously communicate with even other life forms on Earth itself, which is an interesting way of putting it. So how, if we were to establish that communication, how could we approach that?
I don't know. That's a hard problem. We don't I was going to say that we don't kind of concern ourselves with this problem. I mean, we're aware of this problem. We're not, in our searches, we're not directly attempting to communicate with other life. We don't use communication techniques to try to search for the signals that we search for. We don't have any we don't try to use the information that might be contained within the electromagnetic radiation that we observe to try to tease out the signal. We simply look for kind of the properties of the electromagnetic radiation that we know to only arise from technology. I think whether or not we could ultimately sort of communicate with life, extraterrestrial intelligent life, in the sense that we talk to one another, or even in the sense that we talk to our pets, is a very difficult question, an open question, and I think that it will take a lot longer to accomplish that, probably, than to detect advanced life beyond the Earth, which itself might take a very, very long time.
Indeed, probably. Well, I don't know if Mike, you have any other questions. And if anyone else, either here or in YouTube, have any other questions, I guess that we can take a final round. I don't know, Mike, if you yourself have any other thoughts on this. No,
I was just going to maybe finish off by asking Andrew, if he had advice for young people, undergraduates or whatever, and maybe advice, not just from the astronomical sort of perspective, but just in general, how to get involved in this. I mean, I think it is a topic that encourages and loves to have people coming from all sorts of different disciplines. But any advice from you on how to get involved in this if you're a young person coming from all these different areas of expertise?
Yeah, I guess my advice for how to get involved in the research is straightforward, probably advice that you've heard before, which is study hard, get good marks at school, and don't be shy about reaching out to researchers that are engaged in the field. If you read about something interesting, send an email. If you don't get an answer, send another email. Be persistent. I guess maybe that's a piece of advice. Oftentimes people are busy and for one reason or another perhaps don't respond. So just be persistent, and if you don't get the answer that you want from one person, then ask another person. And I think I would also maybe reiterate this point about persistence with regard to your research interests, whether it's the search for extraterrestrial intelligence or rocketry or artificial intelligence or machine learning or whatever it is that you happen to be interested in. Don't sort of take no for an answer ever. I got a great piece of advice a couple of years ago when someone told me, if you have an idea, whatever it is, and you think that you have a good idea, you think that it's an important thing to do, it's a smart idea, be it for a startup company or for a research direction or a particular kind of experiment, and in your heart and in your mind that it is a good idea, then just do it and let other people figure it out. And eventually they will figure it out.
Yeah, I think that's probably, well, I guess you agree, Mike. Definitely useful. A definitely useful piece of advice. We have a final question, I think, from Melissa, which is that if there are any current citizen science projects in SETI that anyone can get involved in. I don't know, Mike. Andrew, I know Berkeley had this SETI at Home project, although I think it has hibernation mode. But I don't know if you are planning on, are there any other initiatives or?
Yeah, you're correct that the SETI at Home program is in hibernation. I'm not sure that it will start back up in the form that it existed before, but there's quite a lot of ongoing work actually to try to extract some scientific insight out of all of that computation that was done over some 20 years or so of the SETI at Home project. Breakthrough Listen makes all of its data public. So we take a very kind of fundamental view of citizen science, which is that we make all of our data public, and we make all of our algorithms public, all of our software, those kinds of things. And we welcome contributions to our GitHub repositories. For example, we have a number of IPython notebooks and things that introduce you to Breakthrough Listen data. So tonight or tomorrow, you could sit down at your computer and download some data from the Green Bank telescope observing Voyager and actually detect a technosignature. In this case, a human technosignature, and even apply those kinds of algorithms to other data. So we certainly encourage anybody that's interested in Breakthrough Listen to look into the public data part of the project.
Yeah, I guess that we are getting to the point that anyone with a computer can do really good stuff. So I guess that we can at least from the society definitely encourage anyone that wants to take a look at the data and see and explore what they can do for themselves. We have a final comment from Subsankar as well about internship opportunities in SETI. I know, as you may know, we distributed the opportunity that Mike and you will pass over about the internships, which I think the deadline has just passed. But we know that these were only in Berkeley, Ireland, here in Manchester, and Italy. And he specifically asked about other countries such as India and Japan. So I don't know if you have any help for him in this sense.
Yeah, sure. So we have, over the last couple of years, we've been internationalizing our internship programs more and more. I think 2 years ago, we had a couple of students in Ireland, and last year we had students in Ireland and in Canada, and also, of course, in the United States. This year, we advertised opportunities at a significant number of additional universities and telescopes, including, as you mentioned, Italy, at Jodrell Bank, Manchester, et cetera. We have a kind of a burgeoning collaboration in India with a university called Amity University. They have an astrobiology group there that's working on developing SETI capabilities for the GMRT, the Giant Meter Wave Radio Telescope in Pune. So I certainly would encourage people to look into that. And if you can't find any information, just send me an email. I'm happy to send it. But I think the goal of our internship opportunity, ultimately internship program, I should say, is to have opportunities around the world. And we don't yet have any in Japan. But if you have ideas for perhaps a telescope or an institute in Japan that might be amenable to having an internship program, definitely do reach out. We would love to try to develop that.
Yeah, well, I hope that's useful, Subsankar. And yeah, I mean, definitely, I didn't know about the opportunity in MIT, but we'll look into that and we'll pass the information. Probably attach it on our newsletter if it's still open. But yeah, I'm provided that with. I think we don't have any more questions. I guess that we can say goodbye to the people on YouTube. And well, thank you, Andrew and Mike, for coming along and for having this short discussion, which has been really insightful, I think. And yeah, if you want to stick around for 1 minute, just while we close YouTube. But yeah, thank you for those that have been watching us on YouTube, and hopefully see you another time.